Hello, my dear students. Today we are going to cover the problem solving part of the bond valuation chapter. Let us start. Okay. In the very first problem, we know this bond will mature 15 years from now. We'll pay 10% annual coupon, which is very important. Then $1,000 par value. And then required rate of return on this bond is 10%. Now, what is the fair value of this bond? Okay. So here, one important characteristics here is we don't know the specific date at which this bond will mature, but we know the date will be 15 years from now. So whenever we don't know a specific date, but we know the number of years after which the bond will mature, then we are going to always use the regular PV formula to calculate bond value. And then in this particular scenario, if we are required to calculate yield to maturity, then we are going to use the rate formula to calculate the yield to maturity. All right, so let us calculate the bond price. So here rate, required rate is 10%, and per 15, coupon 10% of $1,000, 100, negative 100. Remember, if you invest in a bond, then you pay the price right now, and then um, you you are going to receive coupon and then principal whenever they come due. Now, from the issuer's perspective, this coupon payment and principal payment are cash outflow. So we are going to use negative sign here for coupon and for face value or principal value of the bond. Face value here is $1,000. Now you can see present value here is positive. That means the issuer will get present value right now. So it is his cash inflow. Therefore, we are going to use the positive sign. On the other hand, the same issuer will pay coupon and principal whenever they come due. So they are the issuer's cash outflows. Therefore, we use negative sign for coupon payment and for the principal payment inside the formula. Okay. Now, for the same bond, say now the required rate of return ranges from 0% to 30%. Now, let us see how the market price of the same bond reacts with the changes in the market interest rate. Okay, so PV rate and then N per, then PMT, then face value. All right. Whenever the market interest rate or yield to maturity in the market is 0%, then the bond price should be 2,500. Okay, let me see what happens here. Okay. Let me change the formula. In the same way, whenever market interest rate is 5%, then for the same bond, the market price should be 1,519. And then whenever market interest rate is 10%, then the market price of the bond should be $1,000. And then whenever market interest rate is 15%, the bond price should be $708 and so on. Okay. Now, one interesting factor here is you can see here, whenever coupon rate and the market interest rate are equal, then the face value of the bond is equal to the market value of the bond. Here, market value of the bond is $1,000, and then face value of the bond is $1,000. Whenever market interest rate, as you can see here, is less than the coupon rate, then the market value of the bond should be greater than the face value of the bond. On the other hand, whenever market interest rate is greater than the coupon rate of the bond, then the market value of the bond should be less than the face value of the bond. Okay. Now let us show this relationship graphically. So we're gonna put a price on the y-axis and then interest rate on the x-axis. Hit OK. We don't need any chart title. Now here, what we can see, as interest rate goes up, bond price goes down. So there is a negative relationship between the market interest rate or yield to maturity and the market price of the bond. Okay. Now let us see how the price of the bond changes as they moves to the maturity year. And here you can see we have three interest rate scenario. One is 5% interest rate. The another one is 10% interest rate, and the last one is 15% interest rate. And then whenever market interest rate is 5%, then market interest rate is less than the coupon rate of the bond. And then whenever market interest rate is 10%, then the market interest rate is equal to the coupon rate of the bond. And then whenever market interest rate is greater than the whenever market interest rate is 15%, then market interest rate is greater than the coupon rate of the bond. Okay. Now let us calculate bond price across all of these years for these three different interest rate scenarios. Okay. PV, and we know our rate here is 5%. And then N par, then PMT, we know what PMT is here, $100, and then future value of the bond or face value of the bond. Hit enter. Okay, now you can see here, we use the regular PV formula here. Now you can see here, whenever market interest rate is less than the coupon rate of the bond, then the bond is a premium bond. And then whenever market interest rate is greater than the coupon rate of the bond, then the bond is a discount bond. You can see here, market price is less than the face value of the bond. However, market interest rate is equal to the coupon rate of the bond, then the bond is the par value bond. Now, as you can see here, we calculated the value of the same bond in all the years from current year to the very last year of the bond across these three interest rate scenarios. Now, for premium bond, you can see the market price of the bond declines in every year to the face value of the bond by the end of the maturity period or bond investment period. Then the market price of the par value of the bond remains as it is as the bond moves to its maturity year. And then for discount bond, the market price of the bond actually increases to the face value of the bond as the bond approaches to its maturity year. So it is proven from this particular mathematical problem. All right, let us now show it graphically. Select data, add. So let's name it 5% interest rate. And then let us also select the values under this particular title name. And then let us add another line. Let us name it 10%. And let us select the price under this particular 10% scenario. And then let us add another line and let us name it 15%. And then select the prices under this scenario. Let us now put the value for the x-axis. All right. So here, format axis, let us make the minimum value equal to 600. Like here, let us start the x-axis from here. Now you can see value of the premium bond declines to the face value of the bond as the bond approaches to the maturity year, and then value of the discount bond increases to the face value of the bond as the bond approaches to the maturity year, and then value of the par value of the bond remains the same as the bond approaches to its maturity year. All right, now let us calculate YTM. Now here, this bond will mature 14 years from now, and it is now a semi-annual coupon bond. And then let us calculate here the periodic payment. So here you can see face value of the bond is $1,000, and then our annual coupon rate is 10%. However, here we are going to get our coupon payment semi-annually. So let us divide it by 2. Right. So we know now our periodic coupon payment is $50. So now let us calculate YTM. And then here we don't know any specific date at which this bond will mature. So we are going to use the regular rate formula to calculate yield to maturity. Rate. Now NPAR. So we have 14 years investment period for this particular bond, but we know we are going to get our coupon payment twice a year. So total number of periods in this case is 14 times 2, 28. And then our periodic coupon payment is already calculated. Then our current price should be positive, because remember, as an issuer, you are going to receive this price. So we are going to put the current market price as positive. Then as an issuer, you're going to pay um, the face value of the bond. So we put negative sign before this face value of the bond, because it is a cash outflow. Close the bracket, hit enter. Now we got our OITM, but remember, to get this OITM, we use semi-annual information. So we are going to now convert this OITM to the annual term. Now our OITM here is 5.03%. Now, if we want to know our effective OITM, then you already know we are going to apply the effect formula. And then this is our APR, annual percentage rate. And then we know in each year, in this case, we have 2 periods, because we get our coupon payment twice, so 2. So our effective annual rate in this case is how much? 5.10%. All right. Now, here, we now know a specific date at which we are going to buy the bond. That is the settlement date. And then we know the date at which this bond will mature. We know our annual coupon rate. We know our yield to maturity. We know the face value of the bond as percentage of par. And then we know our coupons per year. That means how many times we are going to get coupon payment per year. Okay, so whenever we know a specific date at which we are going to buy the bond and at which we are going to liquidate our investment, that means we are going to get our principal amount back, we are going to use price formula to calculate the bond price or market value of the bond. And then the face value and the market value you are going to use within this price formula. Okay, in price formula, you don't need to use market price. But whenever you use price formula, you need to put over there the face value of the bond, which you are going to get back at maturity. And then that face value of the bond in this formula should be as percentage of the face value. So here you can see face value of the bond is $1,000. And then that is the exact amount we get back at maturity. So $1,000 as percentage of $1,000 should always be 100. Okay. So you can see here it is 100. So equal price formula. Now we have our settlement date, we have our maturity date, we know our coupon rate. So by rate we mean coupon rate. And then here, even if the bond pays coupon semi-annually, you don't need to convert this annual coupon rate into a semi-annual coupon rate. The price formula will automatically consider consider that this annual coupon rate should be converted into semi-annual coupon rate. And then the reason is this: within this formula, you're going to also put a value for this frequency. So from the value of the frequency, this price formula will realize will realize like how this annual coupon rate should be converted into a periodic coupon rate. So again, we are going to now put annual coupon rate. No need to put any periodic coupon rate. Then yield to maturity, same. You don't need to convert. The formula will itself realize how it should be converted into a periodic rate. And then redemption value means the face value you are going to receive at maturity. And then again, it should always be as percentage of the par value. Okay, so $100. And then again, you don't need to put any positive or negative sign inside the formula. The formula will itself adjust for cash inflows and cash outflows. Then frequency, if the bond pays annually, you should put 1. If the bond pays semi-annually, you should put 2. If the bond pays quarterly, you should put 4. So in this case, our bond will pay twice a year. Twice a year, and then close the bracket. Now, the price here we are gonna get with the price formula will always be as percentage of the par value. Now we know our par value of the bond, if nothing otherwise stated, is always $1,000. So this bond price says the market value of the bond is 93.99% of the par value. So that means the actual par value is $1,000 times this percentage. Okay. So one shortcut way to get dollar price of the bond here is this times 10. You can see you get the same value. Or you can just put this way, 1,000, the face value of the bond, 1,000 times this percentage. It is up to you what approach you're gonna follow. Now, here, you know your risk-free rate, you know your inflation premium, you know your maturity premium. Now, the question is, what is the yield on a 20-year treasury bond? So the rate should be risk-free rate, inflation premium, maturity risk premium. And then the yield should be equal to 7.5%. Default risk premium. So government bond is default free, whereas corporate bond has some default risk. So the gap between corporate bond and treasury bond of the same maturity should give you the default risk premium. So let us take the difference between the yield on corporate bond and the yield on treasury bond. Then we're gonna get the default risk premium. All right. Now, in the next formula, we are going to calculate yield to maturity, yield to call, current yield, expected capital gain yield, McCullum, McCallum duration, modified duration. Okay, now here we know a specific date at which this bond will mature, and then the specific date when we are going to make our investment, the specific date when the bond can be called for the very first time. Then we know our coupon rate, we know the current price of the bond, we know call price of the bond, and then we know the maturity value or redemption value of the bond, and we know how frequently we are gonna at what frequency we are going to receive payment in a year. Okay, now let us calculate YTM. So whenever you know a specific date at which you're going to invest and at which the bond investment will mature, you're going to use the yield formula to calculate YTM. So here, settlement date, and then maturity date, and then rate. PR means price, and then here our current price is $93, and then redemption value, that means the face value we are going to get back. And again, within this formula, the price value you are going to use should always be as percentage of the par value. And then next one is frequency, so it is 2. So here YTM is 9.49%. And again, you don't need to convert this rate into annual terms. The year formula itself will always generate annualized YTM. Now, again, as I said, this current price is the price as percentage of par. And then call price here again, percentage of par. And then maturity value here is also percentage of par. Okay, now yield to call So here, whenever we calculate yield to call, we are going to assume that the issuer will retire the bond on the first call date. So that means this is the date at which now we assume that our bond will mature. So okay, our settlement date, the date at which we invest, and then now we are calculating yield to call. So we are assuming that the bond will mature on the first call date. Next, our rate, and then current market price as percentage of par, and then redemption value. So now we are going to consider the call price. So in this case, the bond issuer will actually pay 108% of the face value of the bond if they retire the bond. So the redemption value bondholders should get here is 108, and then frequency to hit enter. So yield to call is 16.27%. Okay, now let us calculate the current yield. So current yield formula, it is annual coupon, dollar coupon divided by current market price. Okay, so annual coupon is how much? Annual coupon is 8.5% of the face value of the bond divided by market price of the bond. And then we know market price of the bond is 93% of the face value of the bond. So current yield here is 9.14%. Now, what is the expected capital gain yield? Yield to maturity is the sum of current yield and expected capital gain yield. Then the expected capital gain yield is the difference between yield to maturity and then current yield. Now, Macaulay duration. So Macaulay duration and modified duration calculates the sensitivity of the bond price to the changes in the interest rate. Okay, now let us calculate Macaulay duration, and the formula is duration. And then to calculate this duration, we need to know our settlement date, we need to know our maturity date, we need to know our coupon rate, 8.5%, we need to know our yield to maturity, and then we need to know our frequency. All right, now Macaulay duration cannot actually is not that much precise, so it cannot give you precise dollar changes for 1% changes in the yield to maturity. And then therefore we have another version of the duration, and then that duration is modified duration. So modified duration is more efficient in calculating the dollar value changes, dollar value changes for a bond, for a 1% increase, for a 1% increase in the yield to maturity, or 1% decrease in the yield to maturity. All right, so let us calculate modified duration, and the formula is M duration. Here we know our settlement date, we know our maturity date, we know our coupon rate, we know our yield to maturity, we know our frequency. So here you can see modified duration is now 6.92%. So here, now you can see current bond price is how much? 93%. Now say yield to maturity changes by positive 1%. So that means yield to maturity is now 10.49%. Now let us calculate bond price with this new yield to maturity. Settlement date, maturity date, rate, yield to maturity, redemption, frequency. Now you can see, whenever interest rate increases, bond price decreases. Now let us calculate the dollar changes here. 93 minus this. So how much? 6.49%. 6.41%. So you can see here, modified duration says if the YTM increases by 1%, the bond price should decrease by $6.92. Provided your bond price is percentage of par, and there in that case your modified duration will also be as percentage of par. Okay, now you can see the actual change is 6.41, and that is very much close to the value of the modified duration. All right, now let us calculate the pure bond price and dirty bond price. And then now, whatever price we see quoted in the market is the pure bond price. But remember, um, whenever we invest we invest in a bond in between the coupon payment date, then we actually pay more than what we can see the market price of that bond in the market. And then the reason is this: somebody actually who actually hold the bond right now already took the first coupon payment and then the last coupon payment, and then they are still holding the bond. Now you are purchasing that bond in between two coupon dates, and then you are the one who will receive the next coupon payment. Now you need to actually compensate this person to hold this bond for some time period after the last coupon date, and then that particular compensation is the accrued interest. And then dirty price is the actual price you pay for your bond investment, and this dirty price considers the pure bond price and then at the same time accrued interest that you need to pay to the current bondholder to buy the bond from him or her. Okay. Now let us calculate pure bond price, and then it is the regular price formula. Then let us put the settlement date. So settlement date here is this, then maturity date, this, then coupon rate, yield to maturity, then redemption frequency. So we know this is the bond price, right? And then here we want to know the bond price, right? So we know this bond price. So this is actually bond price percentage of par. Next, let us calculate accrued interest percentage of par. And the formula is accrued. Next, for this one, we need to know our last coupon payment date, and that is the issue value here. And our last coupon date is this. And then our next coupon date is our first interest date, and then settlement date when we purchase the bond, and then coupon rate, then par value, then frequency. All right. So now we know our accrued interest is 1.69 as percentage of par. Now let us calculate dirty price as percentage of par. So it is 108.06 plus 1.69. Next, let us calculate our actual dirty price in dollar term. So it is, 109.75% of the par value. So this is how we get our dollar dirty price. In the exam, If I don't specifically mention percentage of par, then you should assume that I'm asking you the dollar value of the bond or dollar value of the accrued interest. So be very careful if I am asking for price percentage of par or just dollar value of the price. Okay, now the last problem. So here we have 5 types of securities and we know when they are going to mature. And then now we are going to check the interest rate sensitivity of these 5 different types of securities. Okay, now first let us calculate coupon. So here you can see these are 10-year 10% annual coupon bond, and we know the regular face value of the bond is $1,000, and then we are going to get 10% over the face value of the bond as annual coupon. And remember, this is a annual coupon paying bond. And then the next one is 10-year zero coupon bond. So from this name, we know the coupon we're going to receive here is zero. And the next one is 5-year zero coupon bond. From the name, we know we are going to receive zero coupon payment. And then the next one is again 30-year zero coupon bond. From the name, we know the coupon we are going to receive here is zero. The next one is perpetuity bond, and then again from the information we know the annual coupon we are going to receive here is $100, and then this coupon will continue forever. All right, now let us calculate the price of all of these securities under 2 different interest rate scenarios. Number 1 interest rate scenario is 8%, and number 2 interest rate scenario is 7%. All right. PV, then rate, then NPAR, so we know the maturity, then PMT, next face value, and we know face value should always be 1000. Let me check. And then for perpetuity, the formula should be annual coupon divided by market interest rate, and then again annual coupon divided by the market interest rate. All right, now let us calculate the percentage change. All right, so now you can see here the 30-year bond has the most interest rate sensitivity, and then the 5-year zero coupon bond has the lowest interest rate sensitivity. So from this particular example, what we learned is as the maturity period increases, interest rate sensitivity also increases. That's all from the chapter. Thank you.